a vast amount of our universe is missing. All the known mass just doesn't add up. But a strange particle might offer an explanation. And when I say strange, I mean really weird. It has almost no mass. It is neither positively or negatively charged. It moves at the speed of light. Billions are hitting you and the Earth right now and passing right through you and right through our planet. They're not slowed down by our atmosphere, our deep oceans, or even the core of Earth itself. One scientist described how these ghost particles work. They said it's like shining light through a glass of water. But if we can understand how they work, we could master light speed propulsion, invisibility, walking through walls, and anti-gravity devices. But the strange thing about this real particle is its real presence can't be measured, only its absence. For years, the poor thing only existed as a mathematical probability. Today, enormous sensors like this one in Japan, built deep underground to shield their sensors from all other radiation, have finally detected their presence and proved that this particle is real. This is the strange story of the neutrino. To understand where this ghost particle comes from, we have to first go up in a balloon. In August 1912, Austrian physicist Victor Hess made a historic balloon flight. He was looking for the source of ionizing radiation which registered on his electroscope. The prevailing theory that wiggled his electroscope was it was coming from the rocks of our Earth. But when, in 1911, his balloon reached an altitude of 1,000 meters, Hess found the effect was still there. Wanting to explore even higher, on the 17th of April 1912, Hess made an ascent to an astonishing 5,300 meters. And not on any old day. He chose a total eclipse of the sun. And what he found up there was that it increased by a factor of 3. Neither the rocks or the sun was the source of the wiggle. Hess concluded that penetrating radiation was entering our atmosphere from space. He was right. He had discovered cosmic rays. This is Victor Hess, just back from one of his cosmic ray balloon flights. Hess shared the 1936 Nobel Prize in Physics for his discovery, and cosmic rays have proved useful in physics experiments ever since. These high-energy particles arriving from outer space are mainly protons, nuclei of hydrogen, the lightest and most common element in our universe. But they also include nuclei of helium, and some heavier elements all the way up to uranium. When these cosmic particles arrive at Earth, they collide with the atoms in our upper atmosphere. Boom! Creating more particles, these ones called pions. Charged pions swiftly decay, emitting particles known as muons. Unlike pions, these do not interact strongly with matter, but can travel through the atmosphere, reaching the ground and penetrating anything they touch. Statistically, one of the things they penetrate is our skulls. On average, 1 per second. But why do cosmic rays have so much energy? Clues have come through studying high-energy gamma rays from outer space. Sources of the highest energy gamma rays in our galaxy come from the center of the Milky Way and include remnants of supernova. The most famous source is the Crab Nebula, an old star that's blown up. Shockwaves from these stellar explosions are natural particle accelerators, but some cosmic rays actually come from outside of our galaxy and from supermassive black holes. Studies of cosmic rays open the door to a world of particles beyond the confines of Earth's atoms. All this radiation from space provided the only way to investigate the growing particle zoo of our discoveries. Soon it led to the discovery of the neutrino. In part 2, we'll discover how this strange cosmic ray was discovered and how laboratories all over the world are racing to harness its strange powers. To build light-speed propulsion devices, the ability to walk through walls, and master anti-gravity. The neutrino holds the key to a brave new world, and I've been researching the possibilities for you. So stay tuned, subscribe, press like, and all that good stuff to learn the latest hidden truth about the ghost particle. If you work in the field of neutrinos, let us know what you're up to. That's how this channel works. Because of you and your abilities, the truth is out there.